Hey guys, it's Mr. Vias with the day 6 distance learning lesson. In case you missed the live lesson today, just make sure that you are completing this warm up and lesson by yourself first, then watching your video. So if you haven't done that yet, go do it on your own, then come check your answers with the video. Okay. Also, what's required is that you take that assessment too. So after you did the warm up and the mini lesson, you do the assessment also. It's linked in your Google Classroom, and I expect you to be doing that. So let's get started on this now. So the warm up for each graph, write the linear equation in the form of y equals mx plus b, where m is the slope and b is the y-intercept. So these three graphs I'm looking at right now, they are two of them are different. One is what you're used to. What you're used to for letter C is you're used to the scale of the graph being 1 to 1. So what that means is that you move up one, right? So you can count the slope easier when it's a 1 to 1 graph, when it's a scaled 1 to 1. So you can see the slope is, pick up this point, slope goes up 2, to the right 1. So you're going to get y equals 2 over 1. But since the slope is going down, it's negative 2 over 1 x. And then it crosses out 1. Or you can put y equals negative 2x plus 1. Those are both going to be correct answers for you. Okay. These two ones over here are a little more different. If you look at their scales, they're not 1 to 1. On letter B, the axes are from going up by 1, but the y-axis does not go up by 1. It goes up by 5. Over here, they're both going up by 2. Okay, so you want to make sure you're looking at the scale, so how much you're going up by. It's not always by 1. So for example, letter A, if you were to put 1, 2, 3, 1, that could be wrong because it actually goes up from 2 to 8, which is 6, and from 0 to 2, which is 2. So it rises 6 and it runs 2. So the slope for this one would be 6 over 2, x crosses at 2, y-intercept is at 2. So that's going to be y, or y equals 3x plus 2, right? So make sure you're looking at the scale. And then for letter B, on this one, if we look at this point's a good point, this point's a good point, this point's a good point, this point's a good point. But if you're looking at the rise, if you put 1, 1, you're going to be half right. The rise is not 1 here. The rise is 5. Because it goes 5, 10, 15, 20, 25. So the rise is 5. And the run is 1 in this case because it goes 1, 2, 3, 4, and so on. So it's y equals 5 over 1 x plus 2 plus 0, or y equals 5x, right? You need to put plus 0 there. Okay, now for example, for the next one, examine the linear function represented by a graph in the table, the graph equation and table. So we're going to have to figure out, if you read the statements, the table has a rate of change greater than the equation and graph. The equation has a rate of change greater than the table and the graph. The table has a graph equivalent to equal rates of change. The graph has a rate of change greater than the equation and table. So we got to figure out it looks like we got to figure out the slope for each of these things. So the slope from equation is pretty easy. It's just y equals mx plus b. And so that m right there is going to be your slope, right? So in the equation form, it's really easy to notice right away. So here, your slope, which is equal to m, is 5. Right? And then for a table, you get slope is equal to change in y over change in x. And that's going to be equal to the change in y is 4. The change in x is 2. You can see that. It goes 10, 10, 12, 14, 16, 18, 22, 26, 30, right? Which is 2. Okay. So now for the slope for a graph, that's a little more difficult. Slope for a graph is rise over run, which is, you see it rises here, rises 1, 2, 3, 1. So 3 over 1. So rises 1, rises 3, runs 1, which is going to be 3. So now we know the slope for the graph is 3, the slope for the equation is 5, and the slope for the table is 2. So now we can look at that and look to see which one of these is correct. The table has a rate of change greater than the equation in the graph. No, that's not right. The table has a rate of change of 2. That's the least amount. The equation has a rate of change greater than the table in the graph. The equation does, because the rate of change for the equation is 5, and then it's 3 and 2, so it's bigger than all the rest. So this one would be the one that you want to do. So now the table and the graph have equation equals rates. That's not true. The graph has a rate of change greater than the equation in the table. No, that one is in between these two numbers, so no. So the answer is B for that one. Okay, the answer is B for that one. So now number 3, examine the figures on the coordinate plane. The original, highlight the true statements. The original image was rotated 180 degrees about the origin. So this is the original image. So it goes this way and then this way. So that would be 90 would be down here, 180 would be right here. So this is a true statement. The original image was rotated 90 degrees about the origin. Nope, because that would be down here. The original figure was reflected across the y-axis and across the x-axis. So you're going to go down here, and then you're going to flip down here, and that is true. So let's highlight this one. The original figure, A, B, C, D, A prime is D prime, C prime have equivalent areas. That is true. One of my students said that rigid transformations do not change the shape, so therefore it has equal areas, right? And so that's why this one, the last statement, wouldn't be true either. The segment AE is 1 unit larger than the segment A prime E prime. That is not true also. The segment AB has endpoints. So number 4, the segment AB has endpoints 3, 4, and K, 10, 4. The segment is rotated 90 degrees clockwise and about the origin, then translated 3 units to the left and 2 units down to form A prime, B prime. How long is segment A prime, B prime? So you can see that it's at the same Y. So the X, it goes from 3 to 10 on the X. So therefore, it would be 3 minus 10 would be 7. So it would be 7 units long, right? And you know it's 7 units because it's a rigid transformation, rotations and translations. So it wouldn't change the size of the segment. Okay, thank you. So now explain your reasoning. Okay, so since both transformations performed are rigid transformations, then the length of the segments stays the same. Okay, guys, so that's the end of the warm-up. Make sure that you hit that subscribe button. You leave a comment if you have any errors, or you just want to say, hey, Mr. Rise, what's up? Have a good day.